Today is February 11th, 2023. This is my 225th episode for C++ 17 2023 CUDA SQL OpenGL OpenCL DBB Vulkan. This is 55th episode for vector calculus. We will define Nabla or delta operator, a new programming pattern. The reason I introduce delta operator is that we will implement from vector analysis chapter 7 curvilinear coordinate system. By introducing delta operator, we can completely implement curvilinear coordinate system. For example, orthogonal curvilinear coordinate system. Then I need to introduce tagged type for tensor analysis. In near future, I will introduce tagged type for generalized coordinate transformation. In the current episode, I will introduce a new programming pattern by implementing delta operator. In the near future, I will also implement matrices of functions. With these implementations, we can implement not only curvilinear coordinate system but also tensor analysis. To follow my current session, you need C++ library extension. Before filming video, you can click this link. After filming video, you can click this link to download updated C++ library extensions. From my previous video, episode 224, Vector Calculus 54. In this video, Mr. Hog Wrangler left this message. Do you have videos about fitting data onto cache lines? Yes, I do. Yes, I do. You can search YouTube for cache line with such commands. For example, cache siliconians or align as siliconians. For example, in the search box, cache siliconians, you can find my previous videos related to cache, like this, cache aligned pointer, or align as siliconians. You can find align as, it should be align as. You can find my previous videos about cache aligned elements. Copy. In this video, I fixed. However, I do not recommend explicit cache alignment. If you think a few minutes, you can understand why we should not explicitly specify the cache alignment. If you think a few minutes, you can understand why we should not explicitly specify the cache alignment. Even though we should not explicitly specify cache alignment, we still have to learn what cache alignment means. If you watch through my current video, you can easily understand why we should not. Without further ado, open up Visual Studio Code, CPP 17 2023 parallel. Select empty space, click this button, 225 delta. Sorry, it should be 225. Click this button, delta.cpp, hit enter, Ctrl B. I will close this empty window. I will copy and paste these things. Void test delta operator. Into main, copy the function name, paste it. In function main, right click, go to definition. Right click, go to definition. right click, go to definition. In this file, CPG numerical analysis commands. Here, template, long coordinate system. I will set it 0. Class Nabla. I defined class Nabla. Now, here, inline context per oro delta Nabla 0. Delta operator on the rectangular coordinates system. Copy, paste. I would say del. Copy, paste. Del R. Copy, paste. Delta operator on the polar coordinate system. Delta polar. Copy, paste, paste. On the polar coordinate system, it should be 1, 1, 1. Del P, we can delete this. Now copy, paste delta operator on the cylindrical coordinate system. Cylindrical, it should be 2. Copy this, paste it here. It should be C, 2. Now copy, paste spherical coordinate system. Spherical, it is 3. Copy this, paste it here. Del S, it should be 3. I will delete this. Instead, del rectangular. I will also rename del polar, del cylindrical, del spherical. With this, in this file, calculus.hpp, Ctrl F, gradient. If you find next search here, before Jacobian template, long coord, oro operator, asterisk, Nabla coord operator. We actually don't need this name. Collable with 3 plots C, oro, F. No except this is for gradient. Using namespace CPG numerical analysis commands. We will copy this. Copy, paste it here. Sorry, if context per coord 0 gradient on the rectangular coordinates, I will enclose and indent like this. Else if context per, if this coord is 1 on the polar coordinates, it is not yet implemented. With this, using namespace CPG numerical analysis commands, using namespace CPG operators and constant oro app, we create a function oro x, oro y, oro z, semicolon, return x times y times z. Then oro gradient f equals, we can use del r times f, std cout grad f. For example, 1, 1, 1, grad f 1.0, 1.0, 1.0, CPG, and there. We now test our new implementation. In the command prompt, cd 225 delta clang plus plus std c plus plus 20 delta.cpp ltbb 12 or c.exe, hit enter. I think we made a mistake. 1955. In this file, it should be like this. We fixed, we rebuild. CLSC. So we computed gradient vector using our del operator. Of course, we can do this too. Oro, grad, ff, del r times f. Then we can pass argument directly like this too. Then copy, paste 2, 3, 4, ff. In this case, we don't need provide. We build again. CLSC. I introduced this operator Nabla to extend to polar coordinates, also spherical and cylindrical coordinate system. I will further extend Nabla or delta operator in the future sessions.